All right, now we are looking at section 4.3, so we're kind of jumping around a little bit, but 4.3 is dealing with absolute values. Absolute values, which are the symbols like this, these two bars that we've seen before. Now, funny, we talked about absolute values before. Specifically, we talked about absolute values being more like distance. So, if you're 3 miles north or 3 miles south, we don't say that we're 3 miles away or negative 3 miles away. We just say 3 miles. And that means it's basically the absolute value of that distance would be a positive 3. So the easy way to think about it is whenever something, you take the absolute value of anything, it's going to be the positive. Whenever you take the absolute value of anything, it's going to be the positive. Now, we can use this to solve certain things. For example, if I say that the absolute value of x equals 4, what are the two things that I can put in here that would give me a positive 4? Well, x could equal 4 because the absolute value of 4 equals 4, or x could equal negative 4 because the absolute value of negative 4 equals 4. Okay? So this is the heart of solving equations that use absolute values. So let's do a couple examples. Essentially, whenever you have a problem, let's say x plus 2, the absolute value of x plus 2 equals 3. Okay? Just like this, it could be positive 4 or negative 4. We have to adjust to that. So every time you have an absolute value equation, every single time, your first step is create two equations. Well, sometimes it's not your first step because you got to isolate this absolute value, but you're always going to be creating two equations. So our absolute value sign is already all by itself. So now I'm going to say either x plus 2 equals 3 or x plus 2 equals negative 3. So x plus 2 equals 3, x plus 2 equals negative 3, and then I just solve those algebraically. Minus 2, x equals 1. Minus 2, x equals negative 5. Now I can check this by plugging it back in here. 1 plus 2, the absolute value of 1 plus 2 is the absolute value of 3, which is 3. That's correct. And then over here, the absolute value of negative 5 plus 2, negative 5 plus 2 is negative 3, so the absolute value of negative 3 equals 3. So both of them get me back to my final answer up here. Okay, let's do another example where we have the absolute value of 2x plus 5 equals 13. So again, I would just set that up as two equations. The absolute value is all by itself. If there was like a plus 2 right here, we would obviously just move that over just the same way that we did when we were solving radicals and things like that when we were trying to isolate. Okay? So now I've got 2x plus 5 equals 13. 2x plus 5 equals negative 13, right? And then I just solve. Minus 5, 2x equals 8. Divided by 2, x equals 4. Minus 5, 2x equals negative 18. Divided by 2, x equals negative 9. So now I'm going to plug these back into the original equation and check. So I've got 2 times 4 plus 5, absolute value, equals 2 times 4 is 8, plus 5 is the absolute value of 13, which equals 13. Okay, and then over here I've got the absolute value of 2 times negative 9 plus 5, right? And remember, we have to do order of operations, so 2 times the negative 9 is inside